Yes, give me the value of WU. I think only 1 or 2 minutes.
27.38.
27.38. Point of time, you cannot afford to waste time. So such problems, you'll have to continue and do it. And then working load.
18.25.
18.25. So now we got the working load also. So now you can find out the safe UDL. So safe UDL is nothing but it is self weight of the beam. If you minus, then you will get as the safe UDL. So find out the self weight of the beam. The self weight of the beam is given by P into D into density of concrete. So what is the width? 0.3. Depth is 0.75. कितना आ रहा है? Yes, anyone? Give me the value of the self weight of the beam.
5.625.
5.625. Okay, so therefore the safe UDL is given by total कितना है? 18.26 minus 5.625. How much is this?
12.625.
12.625. So this is the safe UDL. So therefore the safe UDL, the beam can carry is 12.625. Okay, is this clear, everyone? So now let us move to the next problem. Take down the next question, everyone. Calculate the MR. Calculate the MR of a rectangular section 450 by 600 mm. Calculate the MR of a rectangular section 450 by 600 mm reinforced with 3 bars of 25 mm dia. Reinforced with 3 bars of 25 mm dia on the tension side. On the tension side, placed at an effective cover of 50 mm. Placed at an effective cover of 50 mm.
सर रिपीट करो ना एक बार.
Calculate MR of a rectangular section 450 by 600 mm reinforced with 3 bars of 25 mm diameter on the tension side. Placed at an effective cover of 50 mm. Placed at an effective cover of 50 mm. Also calculate limiting MR. Also calculate limiting MR and its corresponding tension reinforcement. Also calculate limiting MR and its corresponding tension reinforcement. Use M25 and Fe415. Use M25 and Fe415? That is the question. Okay, I hope everyone has understood the question, have noted down the question. So in this again, we have to find out the MR, but one more thing they have asked is to calculate the limiting MR. So I've told you limiting MR is nothing but your balanced MR. Okay, it is also called as the ultimate MR. So ultimate MR, या limiting MR, या balanced MR, these all things mean the same. Okay. So now start with this question now, all of you. So what is given? The dimensions are given. B is 450 and D is 600, correct? And AST is given. AST का value बताओ. 3 bars of 25 mm dia. And effective cover is given 50 mm. You can also calculate limiting MR. Use M25. M25 and Fe415. So we have to find out. So first MR find out करना है, फिर limiting MR. Okay. So MU limit you can say, or balanced MR. Okay, AST is 1472.62. So now, give me the value of MR, then we'll find out balanced MR. ठीक है, सबसे पहले we'll find out XU. So give me the value of XU now. You have to be a bit quick now, since we have already solved so many problems. So CU will find out by equating CU equal to T. 131.28.
131.28.
Okay, fine. So XU we are getting as 131.8 mm. Next, give me the value of XU max. So therefore, XU max for Fe415, I think it is 0.08B. So 264. So X is how much? 131. So again, so therefore
260.
is less than XU max. So hence it is N under the first section. Okay, so now we will find out MR. So MR is given by either CU into liver or PU into liver. So give me the value of MR again. 0.36 FCK P into XU into D minus 0.4 XU. Yes, give me the value of moment of resistance. 63.11. Theta is getting. Anyone else? Just confirm me the value. I hope everyone is solving at the same time. If you are not solving, then there is no use of attending the lecture. Okay, so you have to simultaneously work with me. Then only it is useful for you. Yes, what about others? Only one
263.11 kilonewton per meter.
kilonewton meter. Yes, anyone else? Is that correct? Rida and Ojas has given me the answer.
Yes, sir, it's correct.
Right, sir. 260.
So we got the value of moment of resistance also. So now we have to find out the limiting MR. Okay. Now to find out the limiting MR. How will you find out the limiting MR? Limiting MR is nothing but, as I've already told you, it's a balanced MR. So balanced MR find out करने के लिए we already have the equation. So therefore, MR of a balanced section is given by अपना ग्रेड कितना है?
Fe415, M25 and Fe415.
So for Fe415, what is MR of a balanced section? Equation? Anyone?
0.138 FCK BD square.
Yes, 0.138 FCK BD square. 0.138 FCK BD square. Okay, direct, we have remembered it like this. Okay, so it becomes easy to actually solve. So abhi isme just put the values. FCK is 5 and 450 and effective depth. Yes, have anyone found out the effective depth for this? Effective depth
550.
550, sir.
So 550. So give me
469.63.
469.63. So this is nothing but your balanced MR or limiting MR. Okay. So now one more thing is asked in the question. What is that? Now it is asked that calculate the limiting MR and its corresponding tension reinforcement. Okay, corresponding tension reinforcement में पूछा है. So how will you find out that now? Okay, for tension reinforcement.
MR equal to T into liber arm कर दे.
Perfect. So now MR, we know that MR is equal to PU into lever arm. So MR we already have. Balanced MR के लिए स्टील चाहिए तो balanced MR का यूज करेंगे वैल्यू. So this is 469.63. This is 0.87 Fy into AST into D minus 0.42 XU max. Okay, balanced है तो XU max नहीं. So now give me the value of what is unknown. AST is the unknown. So we are finding out AST. Give me the value of AST now. Yes, anyone got the value of AST? Yes, others? Okay, same. Okay, good. 2962.7. So this is your limiting MR and the corresponding tension reinforcement. Okay, so I hope this problem is clear to everyone. So now we'll start with the design of a section. Okay, so now let us start with the Next type, that is design of the section. Okay, so now tell me, while calculating XU, suppose if you are getting XU is greater than XU max, and then it is asked to find out the MR. So what you will do? You're
सर
calculating.
TU into liver arm लेंगे ना फिर?
No.
Redesign.
While
जो
calculating,
बैलेंस MR है वही रहेगा सर.
come again.
जो बैलेंस MR है ना वही रहेगा.
Exactly.
X is equal to XU max.
Perfect. So when XU is greater than XU max, you will consider XU equal to XU max, and then you will find out the MR. So that is nothing but your balanced MR. So remember, it will be under reinforced cantilever. But if XU is more than XU max, then you have to find out MR by considering it as a balanced section. That is XU equal to XU max. Consider करके you have to find out the MR. Is this clear, everyone? Yes, is this clear?
Yes.
Yes sir.
Okay. So now quickly take down the next question, design problem. So now we will design a beam using LSM. Design a singly reinforced section. Design a singly reinforced section to carry a total working load of 50 kilonewton per meter. To carry a total working load of 50 kilonewton per meter over a simply supported span of 8 meters.
सर आपकी आवाज कम आ रही, थोड़ा जोर से बोलो ना.
I'll repeat it. Design a singly reinforced section to carry a total working load of 50 kilonewton per meter. To carry a total working load of 50 kilonewton per meter over a simply supported span of 8 meters. Over a simply supported span of 8 meters. Consider width of the beam as 300 mm. Consider width of the beam as 300 mm. Use M20 and Fe415. Use M20 and Fe415. That is the question.
सर width कितना है?
300 mm. Yes, I hope everyone has understood the question. So let us start with the design. So now what is given in this question? Yes, is my screen visible? Okay, all of you please mute yourself unless and until it is required. Okay. So what is given? The working load is given. So W is given as 50 kilonewton per meter over a simply supported span of 8 meters. Span is given as 8 meters. And the width of the beam is 300 mm. And the grade of concrete and steel is given M20 and Fe41. Okay, is it right? Anything else? Now we have to, what we have to find? So it is asked to design a singly reinforced. So it is already mentioned that it is a singly reinforced section. So we have to design मतलब क्या find out करना है? सबसे पहले तो depth find out करना है and then AST. Is this clear? So now tell me what is the first step here, what you will find out.
वर्किंग लोड को अल्टीमेट लोड में कन्वर्ट करना.
So first, because first we will actually convert this working load into ultimate load. So WU we will find out. So WU is given by 1.5 into 50. So this is the load factor we already know.
$75.
75 kilonewton per meter. So this is nothing but your limiting load or your factored load or ultimate load. So limiting load मिल गया. So now can you find out MU? So therefore MU निकालो अभी. So MU is WU L square by 8. ठीक है, WU is 75. ठीक है, so this is how much?
600.
Yeah, so this is your ultimate moment. Okay, so now for this moment we have to design the section. So now what you will find out after this, once you get the MR. So we know that MR of a singly reinforced balance section is, so now MR of a singly reinforced balance section for FE415. Okay, for FE415 is given by what? Point
0.13.
okay, so now this MR is nothing but your MU, equating MR to MU. So this will be 600, CK is 20, B is 300, and D is the unknown. So find out D from here.
$851.25.
So this is 851.25. So everyone getting the same value? Just write in the chat box. Okay, so now we will, okay, fine. So now let us consider a suitable cover and then find out the overall depth. So let us assume a effective cover. So assume a suitable effective cover and then we will find out the area of C. Okay.
Sir, can't hear you properly.
Yes, am I audible? Is it clear now?
Yes, sir. Now it's fine.
Okay. So now let us consider effective cover is equal to 50 mm. Okay, so let us consider effective cover. So therefore, overall depth कितना हो जाएगा? Okay, overall depth is, this will be 851.25 plus 50.
901.25.
901.25. Okay, so you can take this as 900 also, no problem. So consider या फिर ज़्यादा भी ले सकते हो, no problem. So let us consider overall depth is equal to 900 mm. So therefore effective depth कितना हो जाएगा 850 mm. ठीक है, so don't take this less than 901. ठीक है, because this is the required depth. ठीक है, ये required depth से कभी भी कम मत लो. अभी 850 इससे कम हो रहा है, right? So it is always better कि जो value है, जो required है, उससे ज़्यादा ही लेके solve करो. So in this case, let us assume this as 910. तो ये कितना हो जाएगा 860. So now the second step is to find AST. So when we find out AST, MR is equal to TU into lever arm. So MU is equal to TU into lever arm. So we know that MU is, this is 0.87 FY into AST into D minus 0.42 XU. Okay, so before this you'll have to find out XU max. Okay, so where XU max is how much for FE415? कितना है?
0.48 D.
48.
Yes, 0.48 D. So 0.48 D. तो ये कितना हो जाएगा? D is 860.
412.8.
412.8 mm. Now give me the value of AST. So which implies AST बताओ.
Two four two zero.
2420.276.
2420.27. Okay, so now we got the value of. So now how much steel you will provide? So select a suitable diameter and provide the steel. So let us assume 25 mm diameter. तो कितने number of bars आएंगे? So there
4.93.
25 पे 4.9.
4.93 आ गया. So let us take 5 bars. So therefore provide 5 bars of 25 dia. तो AST provided कितना आ रहा है बताओ?
2454.
2454.37.
2454 आ रहा है.
2454.37.
Okay. 2454.36. So now you got AST provided also. Okay, now what is the next step?
Reinforcement detailing.
Yes. So let us draw the reinforcement detailing. ठीक है, so the depth is how much? 300 by, so this is 300 and overall depth कितना प्रोवाइड किया था?
910. 910.
So this is 910. So bars कितने हैं? 5 bars of 25. So how will you provide? 1, 2, 4, 5. ठीक है, 5 bars of 25 डाल. So this is so this is your reinforcement detailing for this problem. So now remember one thing. So whenever you design any section, okay, after the design, you have to check whether that section is safe or not. Okay, so you have to check two things: whether the section is under reinforced or over reinforced, and whether the section is safe. So that we will do now. So let us check. Okay, so first we will check. First we will find XU. ठीक है, so check किसके लिए? एक तो XU के लिए check है और second MR के लिए. So first we will find out XU. So now tell AST provided. So now we will find out CU equal to TU. So 0.36 FCK B into XU is equal to 0.87 FY into AST provided. Okay, remember this is AST provided. ठीक है, तो AST provided के लिए now we are finding out XU. So since now the AST is changed, so for that your XU will also change. So that is the reason we are checking कि ये जो स्टील जब भी हमने प्रोवाइड किया है तो उसके लिए तुम्हारा XU का क्राइटेरिया सेटिस्फाइड है या नहीं. That means whether your XU is less than XU max or not. ठीक है, so now from this AST provided इधर use करो and give me the value of XU. Quickly everyone, we have only 3 minutes left, so answers दो मुझे. Grade is 20.
410.25.
Okay, 410. Others, is that correct? ठीक है, AST provided कितना है? 2454.36. So which implies XU is 410.25. Okay. So now tell me what is XU max? XU max तो same ही पहले था. कितना था?
412.8.
नहीं, XU max.
412.8.
Okay, 412.8. 412.8 mm. So now compare करो, ये criteria check करना था अपने को. So XU is less than XU max. So therefore XU is less than XU max. So hence it is an under reinforced section. Okay, so even after providing this steel, the section is under reinforced. So this is important. So this we are checking. Okay. So now next is to find MR. ठीक है, capacity भी check करना है. So ये दो check you will have to perform when you're designing the section. To find MR find out करो भी. MR is given by lever arm 0.36 FCKB into XU into D minus 0.42 XU. Yes, quickly give me the value of MR.
Six zero nine.
Yes, what about others? Is that correct? Okay. 609.39 kilonewton meter. So this MR is actually greater than what is the acting moment kitna hai total? 600 kilonewton meter. So hence it is safe. So hence it is safe. So this is your complete design. ठीक है, ये हमने AHT प्रोवाइड करने के बाद चेक किया है कि अंडर इन्फोर्स है कि नहीं, और उसके बाद इसका कैपेसिटी सेफ है कि नहीं. Yes, understood everyone? So this was the design of a beam by LSM.